Hello everyone, it's Wilson here. Today I want to talk about this problem. That's about finding the total area of all the regions. So you may say, how many regions are there? We don't know yet, right? We actually need to graph it to figure out how many regions that are bounded by the curves that are given in this problem. Actually, there is a line here, and then there is a parabola, and then there are two more vertical lines, right? So what happened is that when we are graphing the y equals x and y equals x squared, we only need to graph them between -1 and 1, because once we go beyond those two vertical lines, then the regions are going to be unbounded, so we don't need to worry about those portions of the graph. Okay, so the first thing is that we are just going to just label the xy plane, right? We need to just set a scale so that we can start doing the problem. Okay, so I'm just going to use 3 boxes as 1 unit. Okay, so we are going to just put a 1 here, and this is 1, and then that's -1, this is -1 here. Okay, so we have 3 boxes in each direction for 1 unit, and then we are only going to graph y equals x and y equals x squared between x equals -1 and x equals 1. Okay, so y equals x is really just a line that's going to the points -1, -1, 0, 0, and then also 1, 1, right? So we can just make a straight line here. So we have, let's say we use this line, right? We use yellow to graph this line here, y equals x, and then we are just going to graph the line with this. So that's our straight line right here. And then we have the parabola. This is the most basic parabola that we have here. And then it passes through the points, the origin, which is its vertex, and then the 1, 1, and then also -1 and +1. Okay, so we have the parabola. I'm just doing a sketch right here. So we have the parabola that looks like this. Okay, so we have that. And then the regions that are bounded, okay, would be those two right here. And then you may say this one is unbounded, but then we still have the vertical line that we did not graph, which is this x equals -1 right here. So if we graph it, then we actually will have the region bounded. Okay, so there are two regions that we need to worry about right here. And then, so what really happens is that we have two regions that we need to find the answer of. Okay, so one of them is let's just use blue to shade this region right here. Okay, so there's this blue region right here, and then there is another one. Let's see, should I use green? Okay, so let's just do that. So there is a green region right here. Okay, so this region right here, we have, let's call it A1, and then the blue region, we can call it A2, so that we have A1 and A2. Okay, now, basically, if we are finding the area, okay, if you just want to set up one single integral to find the area, then you can simply set it up as -1 to 1. And then it's really just these two curves that we need to worry about right here. And then you may say, which ones we use to subtract the other one? It doesn't matter, because you are just going to take the absolute value. So I simply would just put x squared, okay, minus, and then the x. Is that okay? And that will give you the area here. But of course, to actually do the calculation, we are going to split up the integral. So if we are to split up the integral, then we are just going to get a1 and a2, right? a1 plus a2. So that's what we need to do here, a1 and then plus the a2. Now the question is, how do you set up the integral for a1? How do you set up the integral for a2? It's actually quite simple. Remember, the idea is that let me just recall the idea right here. So let's just recall that if you have if you have a function, okay, if you have a function that's that's greater than the other function. So let's say f of x is greater than or equal to g of x on the interval from let's say a to b. What happened is that the area is going to be given by the integral from a to b, and then you have the f of x minus the g of x. So you got to use the curve that's on the top, subtracting the curve at the bottom. And of course, we got to assume that f and g in this case, right, by writing this, f and g must both be continuous on this interval. Okay, so that's what we do here. And then we can use that idea to set up the integral for a1 and a2. So now, what is a1? What is a1? So a1 is the red curve. It's at the top, which is the x squared. Okay, so we are going to set up the integral. Oh, actually, we have we go from -1 to 0. Why going from -1 to 0? Because we are going to start from the leftmost x value, which is -1, and then this green region ends at on the right side, which is 0. Okay, so we go from -1 to 0. And then what do we have here? The top curve, which is the parabola. Okay, and then what? Minus the yellow curve, which is the line, right? So we have x squared minus x, and then dx right here. Is that okay? And then now we need the blue region, the area for the blue region. So in this case, we are going to go from 0 to 1. See what's going on here? We go from 0 to 1, the left, the smallest x value for this region, and then the largest x value for this region, 0 to 1, right? And then what do we have here? Now, this time, the line is on top of the curve. It's above the curve, right? So we just put x, okay? So we just put x and then minus the x squared, and then the dx. And so basically, if we find a1 and a2 and then we add them together, then we are going to get the final answer. And so the rest, it's really just routine calculation work. So I'm just going to go faster with the calculation. Okay, so we do the integration right here. We are going to get 1 over 3x to the third power minus 1 over 2x squared. Evaluate from -1 to 0. Okay, and then for the region 2, for the region 2, we are going to get 1 over 2x squared minus 1 over 3x cubed, and then evaluate it from 0 to 1. So continuing with the calculation, then what happened is that if you plug in the 0, you are going to just get 0 for all of them, right? So we get 0, and then minus. Now, if you plug in the -1 right here, that's -1 to the third power, so you still get -1, so you get -1 third, -1 third, okay? And then minus, if you plug -1 in here, you're going to square the -1, so you get +1, so you're just going to get -1 over 2. And then the A2, we plug in the 1, we get 1 over 2, plug in the 1, we get 1 over 3. And then minus, if you plug in the 0, then you're just going to get 0, so we don't need to worry about those. So we can just ignore those, right? And then now finally we are going to do the calculation. What is the final answer for the calculation here? This is, you have this -1 that's being distributed to both terms inside the parentheses, so we are going to get +1 over 3, +1 over 2, and then +1 over 2, right? That's from here, and then also -1 over 3. See what's going on here? The -1 over 3 will cancel each other out, right? So they get canceled. So what do we get here? We just get the answer to be 1. So we get the final answer. So the answer is 1. The total area is 1. Is that okay? So that's actually how you handle this kind of situation when you have more than one region, and when you're setting up the integral from some x value to another x value, and then for some portion of that interval, you have one curve that's above the other, and then for some portion of the interval, you have the curve that was at the bottom now going at the top, and then that's how you handle this kind of situation. Okay, usually we got to do some algebra to find their intersection points, but then what happened is that you actually don't need to, right, for basic functions like this. So it feels like we're at the end of the video, but I still just want to talk about one thing right here, is that we actually can figure out the area without using calculus right here. What happened is that, imagine that you take this piece right here and then put it right here, then what do you think will happen? Okay, so what I want is that I just want to do a note right here on the side, just to point out one fact that we have here, which is that if we place this A2 and then put it right here, okay, so do you see what actually is happening in that situation? What actually is happening is that, let's say you have this curve right here, this is this parabola right here, and then this yellow line. So let me just draw that. So we have the yellow line right here, okay, and then there is that purple right here. So this is our A1, as you can see, right? So we can just, let me just shade this region right here. This is our A1. Now, if we take this A2 and then put it right here where we lay this this portion of the parabola and then just overlap with this parabola, do you see what happens right here? Then we can actually just make them overlap, and then we get that right here. You see what's going on here, and then the blue region now looks like this. Then you may say, hey, what's going on? This is a triangle. This is a triangle right here. Is that okay? And what is the base for this triangle, which is the purple side right here? It's actually 1 unit up and 1 unit down. So there are 2 units for that base right here. Is that okay? What about the height? Well, the height is actually given by this. You see what's going on here? If you just look at the height, what really happens is that the height, as you can see, this is really just 1 unit. So you see that that's just 1 unit. And so how do you find the area for this triangle? Well, the area for this triangle, is that okay? The area for this triangle right here, which is really just 1/2 times the base, which is the purple 2 right here, as you can see. And then times the height. Is that okay? And then the 2 and the 1/2 will get canceled, so we eventually will just get 1 as the answer. See that we get the same answer, and then we only use geometry here to figure out the answer without using calculus. Yeah, that's just one thing that I just want to point out here. Okay, so that's it for this problem. Hope you like this video. To help make math learning available to everyone, please share my videos to others and subscribe my channel. It will give me support and make more videos. I want to work together with you to help students and children learn math more easily. Thank you for watching. I will see you next time.